All right, everyone. So back to where we were at before, right? Doing an ordinal encoder. And so before, right, if you just kind of do this fit transform, it'll transform everything, right? This ordinally encodes every single categorical column. So we adhere to it, right? So if you want to go ahead and just specify certain columns, which is usually going to be the case, okay? What you can do here, right? So we have our dictionary called mapping, and then we have two values, rather two keys, call and then mapping right over here, and the corresponding values are the column label and then the dictionary that we want to use that maps one value to the other. So the idea then, right, if you want to, when you initialize the ordinal encoder, okay, you have an argument called calls, and then what you pass in is a list, right, of the column names, and then there's also a variable called argument called mapping. And this is a list of these values right over here like that. So I'll do this. Okay, and then here we go. All right. Now, of course, these are lists. That means if you wanted to encode multiple columns in your data set, you could follow the same protocol, right? And add your second column over here, and then your second dictionary mapping over there, and then so on and so forth. All right. So that's ordinal encoding, right? And then also, right, we have a one-hot encoder. Okay, like this, so we'll do that. And so the idea then, right, the one-hot encoder, all right, as a default, right, we'll just go ahead and then one-hot encode everything, okay? In a similar vein, right, the one-hot encoder also has an argument here called calls. Okay, and so you could pass in, all the columns that you want to go ahead and one-hot encode. As a default, right, it'll just kind of look at all of your categorical columns. Luckily, though, here, we don't actually have to do this, because the idea is we put the two of these things together in a pipeline. What we can do All right, so the idea then is if the ordinal encoder is listed before the one-hot encoder, the data that gets passed from the ordinal encoder to the one-hot encoder, the categorical columns that needed to be encoded ordinally will already be done. And so what's left over for this guy right over here will just be all the categorical columns. So in this case, if we're passing in the ordinal encoder first, we can just kind of assume that all the leftover categorical columns will be one-hot encoded right over here, right? But now the idea then, right, so if we do this, okay, and so now we say, fit underscore transform, we call this thing, all right? And so what we can see here, right, we have one-hot encoded columns right over here. Okay, and then if we scroll through here somewhere, right, our garage finish column right over here, like this, okay, has been one-hot encoded. If you notice the -1 right over here, so the way category encoders works, if there is a missing value, it'll automatically encode it as -1, like that. That's basically what's going on. Okay, so these are effectively just missing columns in different places, but in any event, the idea is, so this actually is a pretty flexible way, right, to go ahead and then one-hot encode different columns. And so, importantly, right, so we fit this, right, on the training set. And if you guys remember in this lab, one of the finicky problems is there were some values for MS subclass in the test set which were not in the training set, okay? So I believe the value is 150. So before, we had to manually remove it, and then if you didn't, it would have caused you problems. But here, if we just do this, all right, it will go ahead and then automatically encode the test set for us based off the information in the training set, okay? So this is a subtle detail, but it really removes a lot of the grunt work that we've been doing for the last week, and it also makes it very, very easy just to streamline a lot of your operations, especially in production, okay? So here, right, we have the ordinal encoder and the one-hot encoder. Again, in a pipeline, if you want to, you can chain together an estimator at the last step if you would like. All right, so what this means, I'll make a few more here, so I'll do this. So standard scalar. And then also, I'll go ahead. Let me go ahead and then import these. I'll do ridge regression for now. Okay. Just make sure that's done right over here like that. Okay. And so now if I wanted to, okay, I could have this. I'd have the ordinal encoder, the one-hot encoder. After that, I'll go ahead and scale everything. And then at the very, very end over here, okay, I'll have ridge regression like this, okay? And so the idea then, right, if I were so inclined, let's take a look here. One thing, I just want to double check. Okay, no missing values. Okay, all right, it should be fine then. Okay, so the basic idea, and actually one more thing, take a look. Just to make sure I don't get any error messages. Okay, right. So this one, I thought that -1 looked a little bit weird. That's basically like something that wasn't previously encoded. All right, we should do this. And then, okay. Let's rerun this. And then rerun that. Okay, all right. You guys see that? This is kind of a quick idea. So that -1, ideally, like there's nothing encoded here for -1. There are no missing values. So it turns out I mistyped that right over here, and that's why we're getting the -1. So presumably that will be different now. So anyways, so the idea then, right? So we'll go ahead, we'll make our pipe. And so if you think about all the work that we did before, right? On our training set with the encoding, it's actually really important to understand those details. But if you can encapsulate things into a pipeline, okay, what we have now, right? Sorry, I have to do Y. By the way, remember, so when you're using a pipeline, okay, it sort of just takes on the characteristics of the last item right over here like this, right? So because we have all these steps leading up to it right over here, okay, when we call fit on the pipeline right over here, it's basically using ridge regression to do the fitting, and then everything up here is preceding it, okay? So again, you can have the last thing can be an estimator, and then everything before that can be a transformer if you want to. So now we'll fit here. Okay, we have that. And then if we wanted to, right, we could actually go ahead and then make predictions on the test set. All right, and then those would be our predicted values, okay? So I think if you kind of think about the lab we've been working on so far, this is probably a lot easier, right? And if we kind of want to get our final predicted home prices right over here, like this, we could do that. Okay, and so those would be our estimates for the home prices for our Iowa housing data set. And that's a very streamlined way of doing things, right? It kind of does a lot of the hard work for you. And then if we ever had new unseen out-of-sample data, it would just be as simple as taking the pipeline, right? And then go ahead and then calling the predict method on it like that. All right, and then again, when you do that, everything up here is done before it. Okay, so all that stuff pretty much just gets taken care of for you, and it's done in the proper way. All right, so that's kind of the big idea behind pipelines. The last thing I'll point out here is you can also cross-validate pipelines and use them in other sorts of modules. Okay, so for example here, last class, right, we discussed k-fold cross-validation. And so the way this would work then, right, if we wanted to, we could actually take our cross-validated values, rather use the pipeline in cross-validation. So what this means then, if we did this, instead of putting LReg or ridge or lasso, right, we can just put the pipeline like that. And then, right, so X will be equal to train, Y will be equal to Y. All right, we'll use 10 folds right over here like this. And so now if we fit this thing, okay, those are our cross-validator values. So essentially, if you have an estimator at the very, very end, you can pretty much pass it in as an argument just like you would any other model that's built into scikit-learn. All right, so that, right, also very useful. And then something else we discussed previously was cross-validating alpha, right? So remember here, we take a look at our pipeline, right? The last thing over here, right, was ridge regression, and then we have this value for alpha. If you want to use a pipeline for cross-validation, right, to kind of do hyperparameter tuning, you can do that as well. The key here, right, there is this argument here called steps, right? This just returns a list, and every item in the list is a tuple, right, with the combinations of one, the name of your step in the pipeline, and then the actual object itself. So for example, the first item in this list is this tuple, right? And then the second item in that list, this is the actual like transformer object that we initialized right over here, all right? So the idea then, if we go back here to steps, right, the last item right over here is going to be ridge. So if we grab the last item from that, okay, and then the idea is we want this item inside the tuple, so we'll do that. Okay, and that is actually just ridge regression, right? So this thing right over here behaves exactly as if we just kind of initialized ridge itself. So for example, okay, if we do get params, that's a sort of a method for ridge regression that we can go ahead and use. So if you wanted to cross-validate a pipeline, like we did before, like for example, what if you didn't know the ideal value of alpha, right? And you want to go ahead and sort of put everything into a pipeline to make it easier, all right, you could still do something like this. So to kind of pick up where we left off before, we could do something like this, right? Our values of alpha right over here, and then we could do this, pipe, steps, -1, 1, set params, like that, and then we could do this, scores, pipe, okay, like this, right over here. So same thing, right? I'll do this, CV scores. We've already done this before, right? And then just append this right over here. And then the value of alpha like that. So we'll go ahead, just take a look at this thing, and then we'll run it. Okay, and then the idea then, right, we have something over here called CV scores if we wanted to, and so if we take a look at this, all right, this is just what we did in class before, right, except this time it allows us to skip a lot of the pre-processing, and so if we kind of wanted to figure out, right, what value of alpha in the last step of our pipeline kind of gave us the best cross-validation result. It's 100 right over here like this, so then I could just say, you know, pipe, -1, 1, set params, right, alpha equal to 100 right over here. I got some sort of set params. Ridge object does not support indexing. Okay. Oh. I think I have to do that. There we go. All right, so now we could do that. So that was cross-validation. So same thing, right? That's kind of the cross-validated version of alpha that's going to be ideal, right? And so then we could fit our pipeline, right, on the training set, and then same thing, right, if we wanted to, then make a prediction on the test set with all of our encapsulated pre-processing steps. And that's